Hello, everybody. Thank you for coming. I know after coffee break it's difficult. So those ones that don't know me, you can read my name. I pronounce it Strba. This is a talk about reproducible builds. I put my name because you can blame me, but it's this one that has to get on all honor and glory, because that's the Lord. Bernard Wiedemann. Okay, so what are reproducible builds? It's very easy. It's when we get the same results from building sources several times, or at least twice. There are two user cases that we get bit by bit equal results. And there is also a weaker possibility that some timestamps or something can be different, but we can filter it then by tools after the build is done. Why do reproducible builds matter? There are like five points for this. The first one is the security and trust. So reproducible builds, they actually assure that those ones that receive our binaries that they were not altered, because one can rebuild them and will receive the same result. And it decreases the safety of the binaries, also their reliability. Another thing is also for the development transparency. Since we get the same result, we also can be more or less sure that the code will work the same way. And this will make the software consistent and trustworthy. This is for the marketing people, just so that you know. The technical part will come. And it can also protect our built infrastructure, because we will detect the changes in our build system easier, because we will see the differences. Normally, we can already see them, but if we are not reproducible, there are so many differences that they will basically be a needle in the haystack, and we will not find them. So it's the same way like why we are doing warningless code, because when there is a problem, we want to see it actually. And then another thing that is good for marketing people, regulatory compliance and licensing, that we can be sure that actually that the software that we are distributing is a software that corresponds to what we have license for, and that we distribute things that correspond to the source code. And also it can make us resilient against attacks. Because third parties, they can actually check the software and they will get similar results, and they can know, and they can check, like that one, the problem we had with XZ last year. Okay, this was the marketing part. And now the technical stuff. What are the typical problems? The typical problems in softwares are different groups. One of them is that somehow, somewhere, the build systems, they like to, it's like as human beings, when we go to a tree, we like to put our initials on a tree. So build systems, they love to leave traces. So you will find in software embedded timestamps, host names. That is one thing. The other thing is that read-dir order can be random, depending on file system and depending on different things. And also, sometimes software tries to detect the CPU on compile time and then compile according to the CPU that it detected. There are many. Bernard has actually is tracking that in GitHub. The link is there. It's a long link with examples of this thing. But these are the kind of groups. Now, there are also surprising problems. Profile-guided optimization can actually render different results. It can be fixed by always doing the same in the profiling run. I have to explain what is the PGO. That you run a profiling run, and then the result of the profiling run, it gives some file, some information, and the information is used in the compile phase. Or we can remove the files that are different. The result files of the profiling run, we can remove them, and then we lose some optimization, but not all of them. And the other thing is, and this is kind of problem that it's not so easily solved, it's a security that if you have signature, once you sign something with a certificate, you have to timestamp it, because you have to know whether you signed it with the certificate while it was still valid. So the timestamp has to be there, and that's kind of problematic thing, because every time there will be a fresh timestamp. Now, what are the benefits of the reproducible builds? We need less trust in the build hosts, because we will discover if there is a real problem. Now, this second benefit is actually the biggest benefits I've ever seen. It's that load on build service radically improves. We have this Java repository that has about 900 packages, and it was taking forever to rebuild. Once we made the repository more or less to 99% reproducible, we rebuilt it in 1 hour, 2 hours, according to what is the general load. Then, yeah, smaller delta RPMs in update repos, but delta RPMs, I think we are phasing them out. So it's an advantage, but it's advantage in the past. And also, when you build locally, you cache the dependencies, and you have to refetch them less, because if nothing changed, it will not be a new package. Then there are also surprising benefits like counter trusting trust attack. Trusting trust attack is attack when the toolchain itself is compromised and compromises the things that are coming after. And also we can find by trying to be reproducible other bugs. There are 2 examples when basically you can realize when you are trying to make it reproducible that there were other problems. There were some races, there are 2 bugs. The fact that the numbers is 353 and 335 is not a race. It's 2 different bugs. So when the slides are posted somewhere, you can check the bugs. We have them in. There are several other things, but these ones are what I found in the Bugzilla quickly. Now, what we did in Java ecosystem. In Java ecosystem, Java systems, they love to timestamp stuff. And all the default constructor in everything that is time-related, they take a current time. So basically, we had to go through the different source code and look for invocation of new date or construction of some calendars, and make this, like, detect this source epoch. A source date epoch is a variable that we have in the build system that is set when the release is not 0. Once the release is not 0, it set the variable. So and then you can basically set the object to that time. And that one, we are getting it from changelog, for the last changelog. We are parsing the last time in the changelog. So the other thing is that all our Maven internal database is based on XMVN. XMVN is a Red Hat project, but we are using it. And somehow, somewhere in the model, they found it interesting to have the unique identifiers everywhere. So we tried to patch it, but since these parsers are generated, we couldn't just put some number there, because it was actually verifying, the generated parser was actually verifying whether they are unique on the system. So we went with Bernard through trials and errors. So we basically tried to compose kind of string from the date time, from the name of the package, and create a UID from there. Because we can create UID from just a bytes, from bytes. So this was what we had to do for the base package UID. Then this one was for split artifacts. Sometimes you have different XML files that describe the artifact. So we had to basically make it more complicated. We had to take all the artifacts that are in the package, stream them, make some string representation of it, and create the UID from it. The advantage was build system, because build system, this is this one is another way how we try to, so that it's not the same always. So we try to find something that was unique, but something that will be over the runs equal. And the good thing is the open build system, because open build service, because in open build service, we could quickly see whether we got it right and it was building, or we didn't get it right and it was failing because of non-uniqueness of something. So we... so how and at the end, we submitted our patch upstream and it was rejected, but we achieved that now the UIDs, they are optional. So if they are there, the parser reads them, but doesn't care about them. So it's even better solution we got. The other thing is that we generate documentation by Javadog, and Javadog is another thing that loves to timestamp stuff. There is an option for Javadog invocation that is no timestamp, and we had two different possibilities. We had possibility to go over all packages and find where the Javadog is called, or we had a possibility which would be really not optimal, because we would have to every new package, we would have to again audit, and sometimes, sometimes you forget that you have to do it. So, but then we decided to go through the part of the toolchain like Ant, then Maven plugins, and different, and we were looking where it actually invokes the generation, and we added this option into the toolchain. It's our patch. I have kind of problem to upstream everything like this, because there is a lot of discussion then with upstream, and they have always good reasons why they don't want that kind of patch, because why they want to timestamp it. So, but we do it, and it like decreased radically our non-reproducibility of Java packages. Then another thing is when we came to a point where we were more or less reproducible everywhere, we started to pick needs. And one of the needs we picked was that zip file, all the jar files in Java, they are zip files with some metadata, and the zip files have different modification time. So we went again through the toolchain, and we were looking where the zip files are created, and we tried to patch it there. So, for example, this is an example that there is the installer, the XMVN installer that we use to install the packages into the build root, adds something to the manifest, and then it saves the manifest. So, so even if everything was perfectly reproducible, the manifest was having different timestamps. So we looked where it was doing, and we when we simply read the modification time of the original manifest if it exists, and then set the new manifest to that time. It's not a rocket science, but it's just that you have to go and look through different toolchain elements and do it. Now, the other thing is also that Java build system is written in Java. Like Maven is written in Java, Ant is written in Java, and there is a plethora of containers, and these containers, they have different assumptions about ordering. So the interface Java util set has no assumption about ordering, and then there are different implementations that, like hash set is not ordered, it comes as it goes, and then you have linked hash set. That one is keeping order, but it depends also on your file system, how the order is, so that one is also not good. And then there is Java util tree set that is actually an ordered set. The only disadvantage is that it's a slow thing, because every time you enter something in that set, it has to order the whole set. It's some red black tree, but it still has some penalty. But we told ourselves in the toolchain elements, this one is not big deal, because you build once and then the program is running somehow. And then in the worst case, if you find some element and it's still not ordered, you have this Java util collection sort that you can actually sort those things. So that's we were going again through all those elements. The advantage is that Bernard, he has kind of tools that can show you the hexadecimal differences. So sometimes you can actually understand what created the difference the last time. So it was easier to go and look for these things soon. The only problem is that whenever you have to go through the call chain, because once you make something in tree set, but then you call it as a set, internally, it might use another implementation. So it's always trial and error. But it's an interesting thing. Now, we are not the only ones who try to be reproducible. In Maven, the community is also doing things, and they have they actually created this project build output timestamp property that gives a timestamp that should be used everywhere. And the tools, they are using this property. We had, again, two ways to do it. In every spec file, when we invoke Maven, we could give this property. It's kind of funny thing how to say. It means that if the source date epoch exists, use it. If not, use the current date. But then again, you would have to go to every spec file, do it in every spec file. And frankly, I did it in the beginning because I was lazy to look for how to solve it better. But then at certain moment, it was every new package, one forgets, is doing this. So we looked and we went through all the Maven plugins that are using this, like it's jar plugin, compiler plugin, then bundle plugin, that is a plugin that creates Eclipse information in the manifest. All of them, they use it. So I went plugin by plugin and I patched it so that if there is source date epoch defined and there is no timestamp defined already, it just uses the source date epoch. This output timestamp length, if it's equal 1 and there is not digit, it's just their way of overriding, because in Maven everything is inherited. So you have a structure of POM files, and the POM file has its parent. And if there is a timestamp in the parent, and you don't want to use it in the child, so the only way to override it is to give it some value that we know that is not really a time. So it was some ASCII character that was not a number. Because if we give it 0, it still means the beginning of the epoch. So this was what we did then. So the current status, when you look at this, like what we this is all factory. So you can see here we had the Java packages, and basically by these toolchain changes we made many of them reproducible. And you can see even here there were again the modification times that we were doing last year. You can see that they that it has an impact. So now question, why does not everyone do reproducible builds yet? As I said, some of the things have poor performance. So if the performance is important, ordering everything is not an option. Then for certain people, for certain projects, the details of the build, how it was built, on which processor, and what it might be important. Then also generating UIDs, you saw that shenanigans that I had to do there to create a unique but not unique ID. So for you create it randomly, it's much easier. And also, as I spoke about the digital signatures, those ones, they are a hard nut to crack. So now where we want to go. So in factory, we want to fix all build compare issues, because it's build compare that determines whether we declare the package being equal to the previous build. Then produce bit identical RPMs, and then continually verify published binaries for reproducibility to see whether we didn't regress. And when there is a submit request, to try to see whether the submit didn't create reproducibility issues. It's not everything is done automatically, but it's done. So that's the end of it. No, but you can ask if you want, but I will not know how to answer. Yeah. Yeah, that is.
Well, I do have one question. So when I have a source RPM, is there some documented way to reproduce the bit identical binary RPM from just that, or do I so?
Yeah, there are tools. I didn't put them in the presentation. There are tools Bernard has. There it's an invocation where he makes a virtual machine where the virtual he sets different times, and then he compares the builds. And especially we are setting it past 2038, so that we detect in the same time also some time variable problems that can be some overflows. So there are tools. I will check it, and I can actually tell you after. I will look for it. Yeah.
When you talked about being able to verify if the binary RPM we actually published is what was built from the sources we claim it was, I see one problem with that because the resulting binary RPM or the resulting binaries depend not only on the source, but also
on the toolchain.
The toolchain.
Yeah.
So
that's
do we have some means to be able to reproduce what versions of the toolchain were used so that we could actually rebuild the package and check that it's the same?
Yeah. That's a normal problem. Yeah. So what you could basically do is to rebuild it yourself using some time, some revision of in the build system. I don't know really how to do it really. In Java, it's a little bit less of problem because I was actually patching out many of the differences of Java. And then also, if there is like, if it's a GCC, I don't know, because I was working on Java packages. So it's possible that one version to the other, they may create different object codes. That's possible. With Java, the advantage is that at the end of the day, even if you have some difference, you can still see what the difference is. You see, you can see that maybe there was a Java version here or something, but the tools allow you to see hexadecimal differences, so you can see. And the way we ordered it, normally from one toolchain to another, it will not change because the ordering is, okay, unless the internal ordering of the tree set changes between Java versions, but for the while it didn't change. So it's not a panacea. I mean, if it was a panacea, everybody would be on it. But it's like when you do warning-free code. You do warning-free code so that you can actually see what is the problem. Because if it shouts from all sides, then you suddenly don't know what is relevant, what is irrelevant. So
yeah. Anyway,
The reason why I asked was rather whether if we went to some, if we spend so much effort on making the builds reproducible, whether we also did something more to be able to use the benefits.
yes, but
And that's not a question on the reproducible builds. It's rather a question on if our tools like build service actually are able to track enough information to be able to check, okay, this is the binary RPM in the repository, and can I check if it was actually built from the source it claims it was?
yeah, I actually want to say that I think that build service actually stores the informations about the version of packages that were used for building, because at least the kernel live patch packages will like produce live patch packages for each release kernel back 1 year and I don't know 3 months now, and they are supposed to be built using in the same environment as the original kernel. And from what I know, there are currently problems for SLI micro, like in the Git based build service, that the packages are sometimes lost, like the old packages. But it used to work. It did work like with the original build service, and I think that they are going to fix this. Like they have just too many problems, so they haven't got to it yet. But yeah. So
just a quick disclaimer, why you see this model is because I had it all prepared in a text file, because I prefer to write things in text file. And then the Wi-Fi here was not allowing me to go to VPN and get the new model. So I was looking on this computer what model I had, and I used that one. So if you are laughing on the old logo, and higher management, sorry for that, I was not able to download the new template. So
I just wanted to add to the question about how this is tracked and the information is kept. And Adrian works closely together with Bernhard on that, so they will make it. We will work on it further as well. It's not ready there for 16.0, but it will come for that as well. Also, we have software bill of materials which could be used, for example. So there are some things already there and other options. And what happened with Micro 6.0 or 6.1 is something which is related to Git, but actually it was just like bad coding, I would say, and some bad coincidences. And this is kind of these things that will be addressed and are addressed for now. Yeah.
okay, I think we are done.
So I just wanted to mention that this FDO differences with the profile feedback, that's something which we looked into with Martin Liška, and there is a switch for GCC, you know, F minus reproducible minus F reproducible profile info, which is disabling some of the features which typically leads to divergences, because you know, if the build is parallel, you know, the data has to be matched reproducibly. The common problem is that, for example, you have functions which are making temporary files, and the names of the temporary files differs each time you make the build. And if they differ significantly, we might or might not decide to unroll a loop. So instead of removing the file for the complete unit, you can also just disable selectively profiling of such functions, which would lead to minimal damage of the performance, but it's some work. And there's a gsoft dump tool which lets you to dump and identify the function which was which is diverging. So yeah, there's some tooling for that.
And that would be done only for the sake of reproducibility, or
Mhm.
or also done for product build?
That's for reproducibility.
Yeah, because sometimes this problem is that let's try to make the reproducibility not like Volkswagen testing mode. I mean,
Yeah. You know, the other option which we discussed with Richie is that you can also ship the profile data with, you know, save the profile data that your builds will be reproducible. But of course, each time you change the GCC version or change everything, you need to generate them again. So it's not.
or even the builder, if you change the builder. Yeah. Okay, I think we are done, no? Because it's time to go and have a coffee.